Good morning. I hope this video finds you well and you're enjoying your snow day at home. I'm just going to walk you through some of the examples from this handout for you to check and try to explain what's going on. So looking at the first equation here that's in vertex form, notice I'm also using function notation here as well. The vertex here would be a 1, -4. Okay, I get those from, remember, the opposite of the -1 here and then the -4. The direction of opening, since there's no negative out front, this opens up. In fact, there is no A value here, which means our A value is 1. So the step pattern remains 1, 3, 5, 7, and so on, just like the base parabola y equals x squared. Now, the axis of symmetry is that vertical line that splits the parabola in half. That will always be at the x coordinate of the vertex, so x equals 1. Now, I'll leave the range for now. Let's actually graph this, and then we'll see how we can tell what the range is. So vertex at 1, -4 puts it down here. And using the step pattern, I go over 1, up 1 on both sides, and then over 1, up 3 on both sides, over 1, up 5 for the step pattern 1, 3, 5. And the next one will be over 1, up 7, but that's definitely not going to fit. And so there's our first graph, f of x. Notice we can label it f of x. Now let's look at the range. The domain would be all x values, or xer. The range, though, notice that all the y values, or all the f of x values, they're all greater than or equal to -4. So in our range, we're going to write something like f of x, er, where f of x is greater than or equal to -4, just like that. Okay, a little bit easier to find the range once you have the graph to look at. Okay, let's move on to the next example. So in the next example, we have g of x, which has a vertex at -3, +4. This one has an A value, though, that's negative, so we know that it opens down. And the A value is a half, so we're actually going to multiply this step pattern here by 1/2. So our new step pattern is 0.5, or 1/2, followed by 3 halves, 3 divided by 2, which is 1.5, followed by 5 divided by 2, which is 2.5. Okay, we could keep going and following that pattern, 3.5, 4.5, and so on. So our new step pattern, instead of going up by 2 each time in the step pattern, we go up by 1 because we have flattened that out with the 1/2 there. The axis of symmetry will be at x equals -3. And you can either graph it to find the range, or you could do the range right now. I'm going to graph it first. So -3, +4 is right here. Opening down and following this step pattern, I go over 1, down 1/2, then over 1, down 1.5. So there's the half plus 1 more. Okay, the half plus 1 more. Okay, then over 1, down 2.5. So 1, 2.5 puts me there. On the other side, right there. The next one being 3.5. So over 1, down 1/2, and then 1, 2, 3 puts me right at the bottom of the graph right here. Okay, so there it is in green. I'm going to label it g of x. And now I can notice the range here. So the vertex is at -3, +4. And notice all the y values are lower than that. So that's actually a maximum for this one. So g of x er, where g of x is always less than or equal to 4. Okay, and let's move on to the last one. Okay, looking at the last one here, h of x, notice that this one has no value right here. Okay, so there's no shift to the right or the left. It's still in vertex form though. There's just a shift up 6, so the vertex is at 0, 6 here. Because of the -1 in front of x squared, it does open down. And it still has a step pattern of 1, 3, 5, 7, and so on. Since the, sorry about that. Since the vertex is at 0, 6. That means the axis of symmetry is still at x equals 0. I'll graph this one and then look at the range. Okay, so 0, 6, 1, 2, 3, 4, 5, 6 is up here. Over 1, down 1 on each side. Over 1, down 3 on each side. Over 1, down 5, 2, 3, 4, 5 on each side. And there we have h of x, the last graph. I can figure out the range. I could have done this earlier by just imagining what the graph looked like. All the y values are less than or equal to 6. And there you have the end of the first problem. Let's move on to the next one here. Okay, so in this question, you're asked to find the equation of the parabola given the graph. Now, the first thing I would notice in this one is that the vertex here is clearly at 1, 3. So I know that vertex form in general looks like this. Okay, there's an A, an H, and a K value, and then of course Y and X are part of the equation. Now, given that my vertex is at 1, 3, I actually know that H must be 1 and K must be 3, so I can fill those values in. Okay, that's still not quite complete though, because I need to find the A value as well. Sorry about that, I didn't mean to stroke that out. So how do I find that A value? Well, if I look at this, I can see that it opens up. I can also tell what the step pattern is. If I go over 1, it looks like I go up 2. And after that, going up 2, I go over 1. It looks like I go up 1, 2, 3, 4, 5, 6 to get to this point right here. So it sure seems like the step pattern is going to be 2, 6, 10, and so on. So that means that my A value, instead of having 1, 3, 5, 7 for a step pattern, it seems like I have 2, 6, 10, and so I can conclude that A should be 2. And that must be the equation of that graph. The other thing I've said to do is to test a point to see if the equation works. Well, if I assume that, for example, this is a point right here, that's at the point -1, +11. Okay, so what I can do is I can sub in x equals -1 into my answer here, which is right here, and see if I do in fact get 11 for my y value. And that would tell me that my equation is probably correct. So just use order of operations here. -2 squared plus 3. Okay, -2 squared is +4. And then if I take 2 times 4, I get 8, add 3, sure enough, I get y equals 11, which makes me happy. I could have tested other points. I could have tested the point, let's see, 1, 2, 3, 11 is another point. I could have used that to test my equation as well. It wouldn't make a lot of sense to use the vertex to test the equation though, just because it's in vertex form, and so we're pretty sure that that's going to be right. Okay, let's move on to the next problem. So in this example, it's a very similar question, but I think we're going to find that the step pattern isn't obvious. So I can start with the same idea, write it out in vertex form. And then in this case, my vertex is, let's see, -2, +3. So I can fill in my h values with +2. Remember, it's the opposite, +3. Now I want to know what the A value is. In the other example, I could tell what the step pattern was, but in this example, it's not very easy. However, there's a couple points that I can see. I can see that 0, 0 is a point. Sure, it looks like -4, 0 is a point as well. There might be other ones, but those are the only ones that I'm pretty sure from this picture that they fall exactly on those points. Like right here, I can't tell exactly where that is. Boy, that's really close to -4, but I don't think it's exactly -4. So let's use one of these points. I tend to find 0, 0 easier to work with. So what I'm going to do is I know that in my equation over here, I know that when x is 0, y has to be 0 as well. So I can sub that point in. It's kind of like finding the equation of a line in y equals mx plus b form, if you remember doing that last year. So I sub y equals 0 in, and I sub x equals 0 in. And then I can solve for a algebraically. 2 squared is 4, so this is 4 times a. Negative 3 equals 4a. Divide both sides by 4, and I get a equals negative 3/4, which gives me my equation. Y equals negative 3/4, x minus h, oh, sorry, not x minus h, because we know what h is now. X plus 2 squared plus 3 for your final answer. Okay, let's look at the next one. Okay, so here we have an equation that represents something in real life. In this case, it's the height of a volleyball. And the two variables here are h, or h of x for height, and x for horizontal distance. So if we imagine this graph, we can tell from looking at the equation that it is a parabola. So, and we can tell that it opens down because of the negative 2. So it probably does something like this. Okay, you can imagine the volleyball flying through the air. And in this graph, this is horizontal distance here and height here. So it's essentially a picture of the path that the ball were to take. If you imagine the volleyball leaving like a tracer behind it, that would be the graph that you get right here. So the first question here is, what's the initial height of the volleyball? So that's asking, what is this point right here? What is the starting height? Well, the best way to get that is to realize that that happens when x is equal to 0, when the ball hasn't traveled at all. So what we're going to do is we're going to sub in x equals 0, which means we're going to find h of 0. Negative 2 times 0 minus 2.5 squared plus 12.6. Okay, that's negative 2 times 2.5 squared. Okay, or negative 2.5 squared, doesn't matter. Plus 12.6. You would go ahead and use a calculator or something to figure that out. Just give me 1 second here. Make sure I get this right. Oh, sorry. You should get exactly 0.1 meters when you do that. So the initial height of the ball is 0.1 meters. Now I shouldn't really say h equals, I should say h of 0 equals 0.1 meters. The next question asks for you to draw a sketch of the graph and then find the maximum height of the volleyball. Well, notice that this equation up here is in vertex form. So we know where the vertex is. Okay, we know the starting height, so we've got h and x. We know the starting height is 0.1, we just found that, and we know the vertex here is at 2.5, 12.6. Okay, sorry about my sketching, it's not easy to draw on this thing. 2.5, 12.6. The maximum height of the volleyball would be 12.6 meters because that's the maximum value of the graph. The maximum height occurs at the vertex. Okay, let's look at the last question here together. So in this last question, I've started by labeling the vertex. Now it says estimate the equation of this graph, and this graph being time and height. The estimate part comes into play because, I don't know, I think this is at 264. It sure seems like that's 64 here for the y value. And we'll use that for our vertex. So that means if we imagine, again, thinking about the equation in vertex form, we can do some replacement here. First of all, we don't want y anymore. We want h of t. Okay, we don't know a. We don't want x. Instead of x, we're going to use time. Instead of x and y, we're using, of course, t and h. Our vertex is at 264, so we can plug that in just like this. Now, we still need that a value. So just like the other example we did, which is way up here, okay, we can sub a point in to solve for a. Now, I'm going to suggest there's two good points here, 0, 0. And 4, 0 are both good points. I find 0, 0 is easier to work with. So I sub 0, 0 in. So 0 for the height and 0 for time. Gives me this equation to solve. You could also use 4, 0. You'd find you end up getting the exact same answer. You'd sub in 4 for time, but 0 for height still. Okay, if I take -2 and square it, I get +4. Multiplied by a gives me 4a. So 0 equals 4a plus 64. Bring the 64 over. Dividing both sides by 4 gives you -16 for your answer there. So we can then write the equation out. H of t is equal to -16 times t minus 2 squared plus 64. Okay, I hope that that helps you get through this lesson. There's some problems for you to work on right here. I'm always available if you need help, but you'll find these problems are very similar to the examples that we just worked on. Okay.